Using the unit circle, we're going to find the cosine of theta and the sine of theta, looking for the exact answers, not for the rounded values. In order to do this, we need to know a few things first. First of all, we should know that this is the initial side of the angle and this is the terminal side. If it's opening counterclockwise, it'll be a positive angle measure. If it's opening clockwise, it'll be a negative angle measure. So here we have an angle that is opening clockwise, so it's a negative 150 degrees. In order to find the measure of the cosine of theta, which is going to be the horizontal distance out, and the sine of theta, which is going to be the vertical distance out, we're going to create a triangle. So I'm going to use the reference angle here. So 180 degrees minus the 150 degrees will leave me here with a 30-degree angle. So if I pull out this triangle, this is my right angle, this will be my 30-degree angle, which means this angle must be 60 degrees, because the sum of the interior angles of a triangle must equal 180. We know that since this is a unit circle, the radius is 1, so we know that this side is 1 unit long. Using what we know about 30, 60, 90 right triangles, that means the side across from the 30-degree angle must be 1/2, and the side across from the 60-degree angle must be radical 3/2, because in a 30, 60, 90 right triangle, the side across from the 30-degree angle is x, the side across from the 90-degree angle is 2x, and the side across from the 60-degree angle is x radical 3. So if the hypotenuse is 1 unit long, that means that the side across from the 30-degree angle has to be half of that. So if 2x equals 1, then x equals 1/2. So 1/2 times radical 3 will give me radical 3/2. What this means is that I went radical 3/2 units left, and I went 1/2 unit down. Since all students take calculus, we know that when an angle falls in the third quadrant, only tangent values are positive. So this means that the sine of theta, so in this case the negative 150, is going to be a negative value. And the cosine of theta, theta is 150, is also going to be a negative value. Well, the cosine is the horizontal distance, which we said was radical 3/2. And the sine, which is the vertical distance, in other words on the y-axis, is 1/2. So that's going to be a negative 1/2. If we were to write it as coordinates, the cosine value is first, the sine value is second, but in this case it was just asking for the cosine and the sine values. Again, in this example, we're going to find the exact values of the sine of theta and the cosine of theta. And again, we're going to be using the reference angle in order to find these exact values. Now we see here that our angle is opening counterclockwise, so that means it's a positive angle measure. If this is 315 degrees and a full circle is 360, then we're going to do 360 minus 315 to find out the angle measure that's left over. We're also going to create a right triangle. So our right triangle here, if we pull it out, will look something like this. 360 minus 315 is going to leave me with a 45-degree angle. Since I have a right angle and a 45-degree angle, the other angle must be 45 as well. I know that in a right triangle, a 45, 45, 90 right triangle, that my sides across from the right angle is x times radical 2, and across from the two 45-degree angles are x. So if my hypotenuse here is my radius of my unit circle, that means this value is 1. So if 1 equals x times radical 2, I'm going to divide both sides by radical 2. So I get that x equals 1 over radical 2, but to rationalize the denominator, I'm going to multiply the top and bottom by radical 2. I get radical 2 over radical 4, which is just 2. So that means these two sides are both radical 2 over 2. So that means my horizontal distance out is radical 2 over 2, and my vertical distance down is radical 2 over 2. All students take calculus. So the cosine value of the 315 degrees is positive here, but the sine value of the 315 degrees is negative. So I have a positive radical 2 over 2 and a negative radical 2 over 2. Again, as coordinates, if it asked us for the point where the terminal side ends on the unit circle, would be written as cosine first and then sine, but in this case it's just looking for the exact values. Also, keep in mind for theta, you're always plugging in the angle measure that they gave you. We're using the 45 degrees here just to find the horizontal and vertical distance, the cosine value and the sine value. But we're not going to use 45 when we plug it in here because we're finding 315 degrees. It just so happens that this angle gives me a triangle using that reference angle. Lastly, we'd like to find theta. So we're trying to find, in this case, we'll use degrees for theta. We have the coordinates -1/2 and radical 3 over 2. Again, we know that all students take calculus. So that's why the sine value, the y value, is positive, but the cosine value is negative. Because what this is telling me is that the cosine of theta is a -1/2, and the sine of theta is a positive 3 over 2. Well, if I look again at this triangle, I'll pull out this triangle. This is a right angle. The radius for a unit circle is 1. We know that our horizontal distance is that -1/2. So since I'm talking about the actual distance, I'm going to just keep it as a positive number, but I know it's negative because it's in the second quadrant. And my vertical distance is a radical 3 over 2. That means this is a 30, 60, 90 right triangle, which means across from the 1/2 must be the 30-degree angle, and across from the radical 3 over 2 must be the 60-degree angle. That means that this side here, this angle here, the reference angle that we're looking at, has to be across from the radical 3 over 2, so it has to be 60 degrees. Well, from here to here, going around clockwise, we know that it's a -180 degrees, and then an additional 60 degrees makes the angle measure a -240 degrees. So theta has to be the -180 because we're going clockwise, and then the extra 60, so that's a -240 degrees.